Okay, so another question people asked about is example 10.3. Calculate the reluctance of a toroid, a donut, made of low-carbon steel. The inner radius is 1.75, the outer is 2.25. So what that means is, here's your donut. That's 1.75. That's 2.25. So there is a difference here from one side to another, diameter of the donut. In other words, if you bite the donut in half, you get something that looks like this. And this, that is 0.5 centimeters. Now, we're going to have to do some converting of units and all that jazz. So I'm going to get my calculator. For this problem, I actually realized I'm carrying a calculator with me. So I don't have to keep using the one on the computer. So I might be able to get through this a little bit quicker. I'm going to pause for a second. Okay, so this problem, first of all, let me tell you, I understand when people ask questions about this problem. They throw in a lot of stuff in here that, maybe you would or wouldn't know. So so it's 1.75 centimeters to the inside of the donut, 2.25 centimeters to the outside of the donut, and they're saying take the center of the donut for your length. Okay, so the center here is 2 centimeters. Okay. So we're going to get fancy. So first of all, you have to know that for a circle, an area like this, area is equal to pi times the radius squared. The length, which they're saying is take the distance around here, for a circle, circumference is equal to 2 pi times this value, okay, which is going to be 2 centimeters. All right. Now, the pi r squared is half of this. That's going to be 0.25 centimeters is that radius. So, what a pain we have here. This area, I think I need a better marker. This area is pi times 0.25 centimeters squared. And the length, which is the circumference, is 2 pi times 2 centimeters. So, we're going to put all this into the reluctance formula. Do you remember your algebra? Because that's what we got here. So, the L is 2 pi times 2 centimeters. And again, I'm doing this a slightly different way than the book, like I usually do, just to provide alternative. We have this mu value, which I'll throw in a minute. I want to clean up this mess first. Times pi times 0.25 centimeters squared. Ugh. Okay, well, first thing I can do is I can cancel the pi's, make them go away. So this is 4 centimeters divided by mu times 0.25 centimeters times 0.25 centimeters. So, let's see. I get rid of 1 centimeter, and I got 4 over mu times 0.25 times 0.25. Well, let's 0.25 times 0.25 is 0.0625. centimeters. And now the reluctance is, let's see. This is, I'm going to flip this, take 4 divided by 0.0625. 4 divided by 0.0625. That's 64. So now I got 64 mu over centimeters is equal to my answer. And centimeters is 100th of a meter, so 64 mu times 0.01 meters. And then the mu value, they're saying, is 2 times 10 to the negative fourth. So that's 64 divided by 0.0002 times 0.01 meters. Oh crud, and this is with blah 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 blah. Units. I'm not going to worry about it. I'm going to see what my number comes out first. So that's 64 divided by, got two more things from this. 1, 2, 3, 4. So another 0, 2 equals. Okay, let's see, does this work? 64 divided by 0.1, 2, 3, 4, 5, 2. 332, 0, 0, 0, 0, 0, 0. So it's 32 megateslas. Right? Well, I've screwed this up royally. No, I haven't. That's right. All right, I got it right. Because the answer in the book is 31.9 times 10 to the 6. Although I don't have, it's I got the wrong units. It's not Teslas. But I'm going to say I'm happy with getting the number down. Okay, that's a tough problem calculationally. Also, I think it's worthwhile doing it. The book's got it. Chances that you're going to ever run into a reluctance calculation in the real world are pretty darn slim, but I think it's worth doing this just for the exercise of it. Now, the related problem, if you change to a cast steel with a permeability of 5 instead of 2, you make this into a 5 instead of a 2, and that's going to then change this number. So in the related problem, that becomes 5, that's 5, and so you get a different answer. So it's instead of 64 divided by 2, 64 divided by 5, and you're going to get 12.8 million. Weber, Atzi, blah, blah, blah. What are those units? I hope this helps, but this is a pretty difficult problem. Okay, so don't feel bad if you got hung up on it.